Suppose a plus b plus c equals to pi radians. We need to show that cosine squared a over 2 added to cosine squared b over 2 minus cosine squared c over 2 that equals 2 times cosine of a over 2 cosine of b over 2 times sine of c over 2. Let us begin. We'll start our proof from the left hand side. So here on the left hand side, let's rewrite the expression. We have cosine squared a over 2 added to cosine squared b over 2 minus cosine squared c over 2. So first what we'll do, we are going to convert cosine squared b over 2 to the sine equivalent by taking the help of the identity. That means sine squared theta added to cosine squared theta, that's equals to 1, which means that cosine squared theta equals to 1 minus sine squared theta. Okay, so we will convert the second term. So we now have cosine squared a over 2 added to 1 minus sine squared b over 2 minus cosine squared c over 2. Let's rewrite the expression. So we have cosine squared a over 2 minus sine squared b over 2. Okay, so this is going to be one single term that we are going to combine in the next step, and then we have 1 minus cosine squared c over 2. We have 1 minus cosine squared c over 2. Okay, fine. Now, cosine squared a over 2 minus sine squared b over 2, that can be combined by taking the help of the formula. That means whenever we have cosine squared alpha minus cosine squared beta, this transforms to get us product of the cosine alpha plus beta and cosine of alpha minus beta, meaning in our case, since we have cosine squared a over 2 and sine squared b over 2, we should get cosine of the sum of the two angles a plus b over 2, and this is going to get multiplied to cosine of the difference of the two angles a minus b over 2 added to. Now what is 1 minus cosine squared c over 2? This is simply sine squared c over 2. Okay, we are taking the help of the original identity. Now we're going to change cosine of a plus b over 2. So here we'll use the condition, that is a plus b plus c, that's equals to pi radians, which means that a plus b is going to be equals to pi minus c. We're going to divide both sides with 2 such that we get a plus b over 2 equals to pi minus c over 2. Now let's take the cosine function of both sides. So cosine of a plus b divided by 2, that's going to be equals to cosine of the angle pi over 2 minus c over 2. Now cosine of pi over 2 minus c over 2, that's sine of c over 2. In other words, we are saying that cosine of a plus b over 2, this is the same as sine of c over 2. Okay, what we'll do, we'll replace cosine of a plus b over 2 with sine of c over 2 multiplied to cosine of the angle a minus b over 2 added to sine squared c over 2. Now we have two terms, and from the two terms we're going to take sine c over 2 as the common factor, such that from the first term we are left with cosine of a minus b over 2, and in the second term we have sine of c over 2. Okay, so this is going to be equals to sine of c over 2 multiplied to cosine of the angle a minus b over 2 added to, so sine c over 2, again we use this transformation and replace it with cosine of a plus b over 2. Right, this is done so that we can easily add up the two cosine function. Now for adding up two cosine functions, we have a standard formula which is given by, so let's note down the formula. Since cosine of alpha added to cosine of beta, that's equals to 2 times the product of cosine of alpha plus beta over 2 multiplied to cosine of alpha minus beta over 2. So that means we now have sine of the angle c over 2 multiplied to 2 times, so the sum of the two cosine function, that's going to be cosine of Here we can consider a plus b over 2 to be alpha and a minus b over 2 to be beta. So that's going to give us a over 2, and the difference is going to give us b over 2. So finally we get 2 times cosine of a over 2 times cosine of b over 2 times sine of c over 2, and that's exactly the expression on the right hand side. So let's verify it once more. So we needed to show that the right hand side is 2 times cosine of a over 2, cosine of b over 2, and sine of c over 2. So thus we have successfully showed that the left hand side equals to the right hand side. Hence